In the previous video, we implemented our own convolutional neural network from scratch, which can be a lot of fun. However, as we mentioned earlier, it might be beneficial to use a pre-existing neural network architecture. For example, the residual neural network, ResNet. So let's train a ResNet on a new dataset. As always, we will begin by analyzing and inspecting this dataset. And then in the next video, we will implement this ResNet and see how it performs on this new dataset. So in the next two notebooks, we will be implementing residual neural networks. And for that, we are going to use a new dataset. So this dataset, CIFAR 10, is slightly more challenging than MNIST, but don't worry, that's also a dataset that is built into Torch Vision. So we have this CIFAR 10 data module here, where we have then also a data loading based on the datasets here, which is based again on Torch Vision. So there's no need to go to a website and manually download this dataset. So for our convenience, we can just work with this dataset that is already implemented in Torch Vision, which lets us here focus on the convolutional networks and not on the dataset processing. So again, we will start by loading watermark. And then we are going to load the dataset here in order to inspect it. So the data loading here is similar to before. We have a data module that I already prepared for you, and we are going to use again the Torch Vision library for visualizing the images. But before we get to that, it's also useful, since it's a new data set, to look at the dimensions. So for that, we can use the length data module.train attribute to access the number of training examples. So we have 45,000 training examples, and we can do the same thing for the validation data set. So here it's 5,000, and the test data set. So here we have 10,000 examples for testing. And then, you probably know that I like to check the label distribution when we work with a new data set. So let's do that here. So we are going to use the counter again. So this is code that we already used in previous units, so no need to re-explain. So here we are calling it on the training loader, the validation loader, and the test loader. So just to get an idea what the distribution of the dataset looks like. And here we can see that we have 10 class labels, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So that's 10 if we include the 0, of course. And we can see that the dataset is also relatively balanced. So we have about 4,500 examples from each class here. And the same thing is true for the validation set. So we have roughly 500 examples per class and roughly 1,000 examples for the test case here. And then you probably also know that I like to use code to make sure that we have the baseline, which is based on predicting always the majority class. So we can already see, if we use the test set here as a reference, if we always predict the majority class, this would be about 10% accuracy here. But let's validate that programmatically using code. So this is again code that we used in previous units. And as expected, we get 10% here for the accuracy when we always predict the majority class. In this case, it's a tie, so it's just picking a random one. So in this case, majority class is 3. Now let's get to our visual check, where we use the Torch Vision utils make grid function that we used in the previous notebooks to visualize how the dataset looks like. So again, we are going to use 64 images that we arrange in an 8x8 grid here. And as we can see, we have now different objects that are in color. So we have not only objects like airplanes and cars, we also have animals like horses, and I think that's a shark, but I'm not sure. We have a dog here, a bird, and so forth. And actually, for reference, I also have all the classes here so that you can take a look at them. So as we can see, this was definitely not a shark. It must have been maybe a ship or something. I'm actually not quite sure what this is. Could also be an airplane, actually, now that I look at that. So you can see this is quite a challenging data set due to the low resolution. So it's maybe also not super simple for a neural network to classify all these images, because even for a human, I would say it's pretty hard. I think this is a horse, for example, but I'm also not quite sure here. Or in the lower left corner, I honestly have no idea what this is. So in the next video, we are going now then to train a neural network, a residual neural network, to see how the network performs on this data set. So in this video, we looked at a new data set, CIFAR 10. In the next video, let's actually apply a residual neural network on this data set by implementing and training this residual neural network from scratch.